What exactly is a capacitor? Well, in its most simple form, a capacitor is just two conducting plates, kind of like this and this, separated by an insulator. In this case, the insulator that I'm using is air right between these two. So separated by an insulator, and when you charge these with opposite charges, an electric field will exist between these plates. Now, how do you charge them with opposite charges? Well, what you got to do is you got to pull electrons off of this side and put it onto this side. And the way to do that is to connect a battery like this, just a battery, or you could use something a little bit fancier like a Genicon generator like this. And that's what I'm going to use. I'm going to just hook the leads of the Genicon generator, one up to here, one up to this plate, one up to this plate right here. Okay, they're hooked up right there. And what I'm going to do is pull electrons off of this one and put them on this one. Let's go ahead and do that right now. And now there's an electric field. That's good. There's an electric field right between these two. And I can get the electrons to move back to where they started just by connecting these two plates. Now, to show the actual effects of this, I've got a much better capacitor, believe it or not, even though it looks smaller, it's a much larger capacitor, maybe 10,000 times as large, as much capacitance. I'm just going to hook these two right here. Again, what's inside here is just two plates. It is rolled up. There are two separate plates separated by an insulator. It's all rolled up. That's how it can fit into here. But let me show you what happens when I connect the two leads of this Genicon generator to my 1 farad capacitor here, and I turn this. I'm pulling electrons off one plate, putting them on the other plate, and then when I let go of this, look what happens. It just keeps going. What's happening is the electrons are draining back the way they came, which happens to make this thing turn in the same direction. We can do all kinds of cool stuff with this capacitor. I'm going to charge it up again. Then I'm going to disconnect it. Now what I've got is on this capacitor right here, charge trapped on it, negative charge on one side, positive charge on the other side, and I can do all kinds of cool stuff with this charge. Like, here's a light bulb. Watch what happens when I connect this end of the light bulb to my positive terminal and this end to the negative terminal. See if you can see this. Hey, it lights up. But unlike a battery, you will see that within a few seconds to a few minutes, you can see that the charge is draining off of there. This is getting dimmer and dimmer and dimmer, and it won't be too long before all the charge has drained, and then the bulb just goes out because there's not enough current to keep it lit. So these are a lot like batteries, except you can charge them and discharge them, charge them and discharge them, pretty much ad infinitum. So this is actually a great area of research using ultra capacitors instead of batteries. This may be a fantastic way to store renewable energy, and we'll see what factors affect the capacitance so you can kind of start imagining how you can build the next ultra capacitor. Basically, all a capacitor is in its most simple form, two plates which are charged oppositely, separated by some distance. By the way, it could be a vacuum in between the two plates as well as an insulator. Here's a little capacitor demonstration from the phet.colorado.edu website. You can see what I have here is two parallel conducting plates. It gives you the separation of the two plates here and the plate area right here. And I've got them connected to a battery. This is just the most simple capacitor you can get. You'll notice that when I turn up the voltage here, I'm turning it to a positive voltage, positive charge migrates onto this plate, but where did that charge all come from? It had to be drawn off of this plate, and that's why there's negative charges right here. Positive charges pulled off there and pulled into there. So you can see that the charge magnitude is the same on both plates, although one plate's positive and one plate is negative. I can also, if you want, on this type of capacitor, you can just reverse the polarity. I'll just flip the battery upside down, and you notice I can have positive charge on this plate and negative charge on this plate in the same way. Not every capacitor can you do that on. On electrolytic capacitors, you have to polarize them a very specific way. Here are a couple different styles of capacitors. So the one I showed you already, maybe you can see that this is labeled with 1 1 farad is its rating, and it says it's at rated for 5 volts maximum. There's another capacitor right there, and here's yet another style of capacitor. For this electrolytic one, you can see it's got a negative, a bunch of negative signs on it. This one you must hook up the right side, the proper side to negative, or it will explode. And this is why that's so carefully labeled with negative, negative, negative over to here. So this is the negative terminal of that thing.